Hello everyone, this is our video lesson for SOCS. So SOCS stands for Shape, Center, Spread, Outliers. And it is the acronym that we use to remember all of the things that we need to describe when somebody asks us about a distribution. I have made the decision to film this lesson because I want to make sure that I include everything that we need in order to be successful at this, because we see this throughout the entire year, and there is always at least one free response question where you are asked to describe a distribution. So because of that, I want to make sure that all classes get the same information and all of the information that we need in order to do this correctly. So with that being said, we are going to take our notes on this cardstock that I gave you that's called Describing the Distribution of Data. And then our acronym is SOCS. We say it's socks, and every time I see it, I always think about a pair of socks. Now, when I go over what this stands for, I always say shape, center, spread, outliers. So notice I don't go in order. I don't go shape, outliers, center, spread. It just makes more sense to me to say shape, center, spread, and then outliers. So let's just get going on what they expect us to describe when asking about shape. So, is the distribution symmetric? So when we plot all of the data values and make a graph, is what we see symmetric? What that means is, can you fold it along a vertical line through the center and have the edges match pretty closely, or are more values on one side? So one thing that we look for is it symmetric? We're looking for symmetry. Now, it doesn't have to be perfect. When you, in your mind, fold that distribution in half, the data doesn't have to line up perfectly, it just has to be close. In fact, you're very rarely going to see a distribution that is truly symmetric, like 100% symmetric. So if we turn this cardstock, we're going to get some examples of graphs or distributions. We're going to identify which ones are symmetric. So this first one, he's not perfect, but I would definitely say that this first one is roughly symmetric. We're writing roughly symmetric. We're not writing symmetric because it is not perfectly symmetric. It is approximately symmetric. So you can use the word roughly or approximately. I use roughly because it's shorter, just being honest. Then this one below it right here, he is also roughly symmetric. So remember, this is like if you fold it vertically through the center, will the two sides match up pretty closely? This guy, I'm like, is he not? He's not. If we found the center of this guy, that's about right there. And if we folded that in half, I don't think that these bars line up quite close enough to be called roughly symmetric. So this guy, he is not roughly symmetric. This last one here, he is symmetric. Not roughly symmetric, he is exactly symmetric. If we folded this graph in half down the center, those two sides of the data would match up directly. So when we're talking about you can fold it in a vertical line through the center, we're literally talking about folding it. So I can fold, this is one of our can you do's. I am going to fold this down the center of the graph. So we literally mean fold it, and then we ask ourselves, do the bars line up? So if I held this up to the light, would the bars line up? And the answer is no. So you literally identify the center of the distribution and ask yourself, is this side approximately the same as this side? Okay, the next thing that it might be is skewed, and I think we're all familiar with skewed distributions at this point. The thinner ends of a distribution are called tails. If one tail stretches out farther than the other, the histogram is said to be skewed. And the side that it's skewed toward is the side of the longer tail. So we've talked about that as the skier. It is skewed toward the direction the skier would be skiing down toward. So on the back of our page, this middle top graph, he is skewed to the right. And the last top graph is skewed to the left. So skewed right, skewed left. So symmetry, it can be symmetric or it can be skewed. Does the graph have one central peak or several separated peaks? These peaks are called modes. So when we first learn to describe a data set, we talk about mean, median, and mode. Mode is the number that shows up the most often. So it would make sense that that would be a peak, because the reason that part of the graph is so high is because there are so many observations at that part of the distribution, and we would call whatever number that is a mode for the distribution. So if it has 0 modes, meaning no peaks, it's uniform. 1 mode is unimodal, 2 modes, bimodal, 3 or more modes, multimodal. So I would recommend you pausing the video to see if you can label these graphs based off of their modes. So you don't have to write anything down if you're not feeling confident, but I would at least pause and see if you can identify unimodal, bimodal, multimodal, uniform. Okay, hopefully you guys was really doing that, family. So we would say that this first one is unimodal. And he has a single peak. He has one peak. And sometimes you'll hear it referred to as like a single central peak. So what that means is that the peak is in the middle of the distribution. The skewed right and the skewed left are unimodal. You would say on both of these, they have not a central peak, sorry. They have, both have a single peak. So I guess on this one, you don't even need to say the word single, because you can't have more than one central peak. If it's the central peak, that means it's in the center of the data and there isn't more than one center. Okay, this guy, no modes, no modes. You would say on this one, there is no single peak. He would be uniform. I know that there are some bars that are higher than other bars, but if you look at the overall picture of the data, we would say that this is uniform. The best description for the next one would be multimodal. Multimodal. And then the best description for our symmetric distribution is bimodal. Bimodal. So this is all of the information that we need to keep an eye out for when we describe the shape of the distribution. So we're looking for symmetry. We're looking for if it's skewed. We want to note if there is one peak or more than one peak. And then one last thing that it is easy to forget, I just forgot it. I thought we were done going over shape, but you want to mention if there are gaps in the distribution. And if there are gaps in the distribution, you always want to give a specific value or values. So if you're going to say there is a gap in the data from 40 to 55, you want to actually say 40 to 55. You don't just want to say there's a gap in the data. You want to say there is a gap in the data from and to. Or there is a gap in the data at 6. Whatever the situation is, you just want to make sure that you use specific values. And I hope that you are recognizing that this idea of giving values, even when it's obvious, so even when the grader can look at the paper and see, well, yeah, there's a gap, even though it is obvious there is a gap, and where the gap is by looking at the picture, they still want you to mention it in your description. It's just like when we were doing two-way tables, and even though you calculated your percents and they were very obviously on the paper, you still had to use those percents in your response to get full credit. So that is a similar situation here. You want to make sure that you always give specific values if you're talking about gaps. And then this says gaps help us see different modes and encourage us to notice when the data may come from different sources or contain more than one group. So on this backside, we don't have, at least in our shape section, we don't have any that have gaps. Down here in our outliers section, though, every single one of these has a gap. This one has a large gap. This guy has a very large gap. So